For today's adventure, you're going to need an Arduino, a ultrasound sensor, 4 female-to-female cables. You're going to need some addressable LEDs, or any other LEDs really. I'm using LED addressables because that's what I have on me. I'm using these fancy connectors for the addressable LEDs. Just because they tend to be a little fragile otherwise if you're just directly soldering onto them. You need a butt ton of cables, ideally female at one end, but the other end we're probably going to be stripping so we can put into the connectors. And you're going to need a power supply for your Arduino. So the first thing I'm going to do is I'm going to cut it at about this point here so that I have a bunch of flat pads to connect to with the connectors on this side. As you can see, there's kind of tiny spikes, and that's where the tiny spikes go. And remember to go on the arrow on this side of the arrow because the connections go in that direction. So it turns out the connectors are a pain to use, so I ended up just soldering the wire on there and then using some hot glue to keep it on there. The way I'm testing connectivity on these things is I'll connect ground to signal and 5 volts to 5 volts, and you should see some very dim lights on the first guy if they're connected correctly. Also, don't connect them backwards because they will explode. Alright, so it looks kind of complicated, but basically what I did is I connected all of the 5 volts to one connector. I connected all the ground volts to one connector, ground volts, and then each of the control ones I connected to a different color. So one of them's red, one of them's yellow, and one of them's green, which then should make it easier to figure out which one's which when I connect it to the software. So just to go over this mess of cables, let's start with the ultrasound. I've got, the VCC and the ground, and those are the red and the green, and you'll see that they are connected to, don't look at those red green, here we go, the 5 volts and the ground, and then the yellow and the orange are connected to 6 and 7. Meanwhile, the lights managed to work on 3.3 volts. They don't have to be too bright. And so those are connected, the black one being to ground, and the white one is connected to the 3.3 volts. And then I've got the red, yellow, and green cables connected to 10, 11, and 12. Alright, so here's the code. It starts out with measuring setting up pins for the ping and the echo on the ultrasound. Then it gets a little jumbled, but basically I need to start up with the lights and the ultrasound and telling the Arduino that I'm going to be using those and bringing in those libraries. So then we bring in the fast LED library. We tell it which pin the red LED strip is going to be connected to, the yellow one and the green one, which will be digital 10, 11, and 12. These strips at the moment only have 7 LEDs on them, so I have to tell it that. I set up a default brightness, although I think I changed that later. And then the LED type and the color order, just kind of, you'll know that from your type of LED. And worst case, it'll just show up backwards and you just have to change it when you're testing it. And then you have arrays for each of those strips. So if I have 7 LEDs, I need an array of 7 so that the code knows where to put each color. And then updates per second is how often it's changing the colors or setting up the new colors. So like in a Arduino code, you've got your setup. There's a safety delay for the LEDs. And then we tell the fast LED library to get ready with the LED type and the LEDs, which arrays is each thing going to be connected to. And we set the default brightness, and then I also have some debugging stuff here. So in the main loop, we first do the pinging stuff for the ultrasound. So we initialize the time and the inches. We basically ping we send out a ping, low, high, low, and then we read it from the echo. We try to read the echo from the echo side, and then we set the duration for how long it took the ping to go out and come back, and then we convert that to inches using the speed of sound. And then we can print that if we want. And then once we know how far away the object is, we can then set up an if statement. And I could do if else too, that would have worked as well. But basically, if inches is less than 10, then loop through all the lights, and if the lights are on the red strip, then turn on the red lights. So red, RGB, red, green, blue. So we got to do all red, no green, no blue, and that'll turn on the red strip. And then, similarly, we want to turn off the other ones, so that's 0, 0, 0. And just to go through another one, if it's between 10 and 20 inches, then we want to turn off all the red and the green ones, and we want to turn on full red and full green, which, if you remember your colors, will make you yellow. And then finally, once you've set up the arrays, then you have to tell it, like, okay, put these arrays out, output these, print these, publish. And so fastled.show will do that. And then finally, there's just a quick function that converts microseconds to inches. So for prototyping purposes, I have the power connected to the wall, which goes to the Arduino, which is duct taped to the wall right now. And then we got the lights somewhere where the driver can see them, and the ultrasound pointed at the car.